Now we will talk about, again, good evening. We will talk about the microcontroller. So, example, microcontroller here. I have here the Arduino, okay? As what I've shown you earlier. Um, what is a microcontroller? So, a microcontroller is a chip optimized to control electronic devices. It is stored in a single integrated circuit, which is dedicated to performing a particular task and execute one specific application. So, it is specially designed circuits for embedded application and is widely used in automatically controlled electronic devices. It contains memory, processor, and programmable IO. That's why this small piece here of microcontroller, it has already its memory, processor, and programmable input and output, because we have pins here. You can put pins here and connect different with different sensors, motors. For example, we also have here. This is actually the brain of the microcontroller. So this is an integrated circuit here that accepts program and code. Now let's talk about microprocessor. A microprocessor is a controlling unit of a microcomputer wrapped inside a small chip. It performs arithmetic logic unit, or the ALU, we call it ALO operations, and communicates with the other devices connected with it. It is a single integrated circuit in which several functions are combined. So, microprocessor, types of microprocessor: complex instruction set microprocessors, the application specific integrated circuit, reduced instruction set microprocessors, and digital signal multiprocessors. You just have to remember these things. I might include this with questions later on if we have. I will assign you with quiz assignments in our Google Classroom. Types of microcontroller: we have 8-bit microcontroller, we have 16-bit microcontroller, 32-bit microcontroller, embedded microcontroller, and external memory microcontroller. So, for the 8-bit microcontroller, this was previously as designed. These are the first of those microcontrollers, and then the evolution happens. Then there's 16-bit microcontrollers, then there's 632-bit microcontroller, and we also have embedded microcontroller, like for example this one, the Arduino microcontroller, and the external memory microcontroller. Let's talk about the history of microprocessor. So for the microprocessor, Fairchild Semiconductors invented the first integrated circuit, as what we call it as IC, in 1959. In 1968, Robert Noyce, Gordon Moore, Andrew Grove found their company Intel. So that's why we have Intel right now, because of their microprocessors. Intel grew from 3-man startup in 1968. Imagine, there are only three people starting the Intel to industrial giant by 1981. So it took them around 13 years before they become an industrial giant. So if you have plans ahead, you still have time to create your company. So in 1971, Intel created the first generation microprocessor, the 4004, that would run at clock speed of 108 kilohertz. So imagine, during those time, it only has a 108 kilohertz. Now, like for example, on my PC, on my laptop, I have here the 2.30 gigahertz now. Okay. So imagine, kilohertz, it will still undergo the megahertz and now the gigahertz. So that's the evolution of our microprocessors. From 1973 to 1978, second generation 8-bit microprocessors were fabricated, like Motorola 6800 and 6801. We also have the Intel 8085 and Zilog CZ80. So these are actually the first of those microprocessors introduced in our communities in the world. For the history of microprocessors in 1978, again, Intel 8008 third generation process came into the market. So again, we have the 4004. But in 1978, they already created the Intel 8008, which is much faster compared to the 4004. In the early 80s, Intel released fourth generation 32-bit processors. That's why we have the 32-bit and the 64-bit. So it was in early 80s. In 1995, Intel released its fifth generation 64-bit processor. So there are all for our 32-bit and 64-bit in our laptops, it's actually the architecture itself. So if we have 32-bit processors, 64-bit processors, so there is actually a difference between these two. So for the history of microcontroller, first, the microcontroller actually used in 1975. So Intel 8048 so for the microcontroller. And then there's the introduction of EEPROM in 1993. The EEPROM is electrically erasable programmable read-only memory. So we know what read-only memory is, but for the electrically erasable programmable read-only memory in 1983, so that's why we have microcontrollers that we can program and we can actually delete the program once we overlap it with the new program. The same year, Atmel introduced the first microcontroller using flash memory. Okay, Atmel is one of the most famous in electronics industry. For the features of microcontroller, program and variable memory, so RAM and I/O pins, device clocking and central processor, and instruction cycle timer. So these are highly technical things to consider, but these three are the main features of microcontroller. For the features of microprocessors, offers built-in monitor debugger program with interrupt capability, large amount of instructions, each carrying out a different variation of the same operation. Offers parallel input-output, instruction cycle timer, and external memory interface. So imagine, these are also technical, but if we're familiar with these things, these are actually the features of the microprocessor. So microprocessor versus microcontroller. Microprocessor, okay? So these are comparisons. For microprocessor is the heart of computer system, as we all know. On the other hand, microcontroller is the heart of an embedded system. So there's a difference between a computer system and an embedded system. Like for my, I've shown you my Arduino Uno R3 microcontroller. So if I build a firefighting robot, I'll be using this one. So that's an embedded system because it has dedicated functions. It will only be a firefighting robot or line tracing robot or some robot. While microprocessors can perform a lot of tasks because as we have read here, computer system. So we can find it in our system units, microprocessor. We already have i3, we have i5 and i7. Okay, so microprocessor because these are tiny things already that you can actually fit in your pocket. So microprocessors in reality are much smaller compared to this Arduino board, but this Arduino board here can already perform a specific task and whatever program that you will input there. So for microprocessor, it is only a processor, so memory and I/O components need to be connected externally. Okay, that's why we input USB in our system units or our computers. Microcontroller has a processor along with internal memory and output components. For microprocessor, again, memory and input-output has to be connected externally so the circuit becomes large. Memory and input-output are already present in microcontroller and the internal circuit is small. You can't use it in compact systems. You can use it in compact systems for the microcontroller. Microprocessor cost of the entire system is high, so it's expensive. We know that for a fact, and the cost of the entire system is low. That's why I only need this one. Due to external components, the total power consumption is high. Therefore, it is not ideal for the devices running on stored power like batteries. As external components are low, total power consumption is less. So this is electricity saver or energy saver. So it can be used with devices running um, on stored power like batteries. For the microprocessor, most of the microprocessors do not have power saving features, while microcontroller has one. Microprocessor is mainly used in personal computers, as we have talked earlier, but microcontroller is mainly in washing machine, MP3 players, and embedded systems. Microprocessor has a smaller number of registers, so more operations are memory based. That's why we have our hard disk drive or the solid state drive or SSD. Microcontroller has more register, hence the programs are easier to write. Microprocessor are based on new von Neumann model. So we von Neumann model is for the architecture of our system units or our microprocessors, including it. And microcontrollers are based on Harvard architecture. So von Neumann model and microcontroller is Harvard architecture. Microprocessor is a central processing unit on a single silicon-based integrated chip. So, microcontroller is a byproduct of the development of microprocessors with a GPU along with other peripherals. So, for microprocessor, it has no RAM, room, input, output unit, timers, and other peripherals on the chip because it's externally connected and attached to a single motherboard. While microcontroller, it has CPU along with RAM, room, and other peripherals embedded on a single chip. Microprocessor uses an external bus to interface to RAM, or random access memory, read-only memory, and other peripherals. It uses an external controlling bus, okay, for the microcontroller. We also have, for microprocessor-based systems can run at very high speed because of the technology involved. So this is where the comparison also, because of course, microprocessor are fast in terms of high speed calculation. Microcontroller-based systems run up to 200 megahertz or more depending on the architecture. Microprocessor used for general purpose applications that allow you to handle loads of data. Okay? That's why we can perform a lot of tasks using our computers because it has a sturdy and rigid microprocessors, while microcontroller is used for application specific systems. So we just have to remember that microprocessor can perform a lot of tasks, while microcontroller are application specific systems. That's why on our embedded system discussion, embedded systems are really specific in terms of its output and in terms of its capability. It's complex and expensive with large number of instructions to process. That's the microprocessor. For microcontroller, it's simple and inexpensive with less number of instruction to process. So that's the microcontroller. Now, what are the applications of microprocessors? So microprocessors can be calculators, accounting system. We can make calculators, accounting systems, game machines, complex industrial controllers, traffic light, control data, military applications, defense systems, computation systems. Because we all know that microprocessors are fast enough to handle these applications. What are the applications for microcontrollers? Microcontrollers can be on the mobile phones, automobiles, CD players or DVD players, washing machines, cameras, security alarms, keyboard controllers, microwave oven, watches, and MP3 player. So these are the applications of microcontroller. Features of microprocessor. Mic offers built-in monitor debugger program with interrupt capability. Large amount of instructions, each carrying out a different variation of the same operation. Offers parallel input-output, instruction cycle timer, external memory interface. Okay. So I think that's all for the microcontroller. If you have questions, you can actually ask it now.